Hey guys, this is Michelle Trin. I'm going to show you how to make a combined Koa and Poisal flow in Fluent. This is for Ausbase class in summer of 26, so let's get started. First, we are in Fluent. We're in our workbench right now. First thing we're going to do is drag Fluid Flow Fluent over. We're going to right click on our geometry, go to New Design Modeler Geometry. Wait for that to load. Okay, first thing you're going to do is change your units from meters to millimeters. And then you're going to create a sketch. We're trying to make a rectangle in our XY plane. So click rectangle, start it at the origin, and then we're going to add dimensions to that. So if you click dimensions here, we're going to go to length distance, and start with making the length. So this length is going to be 250 millimeters. Okay, now we're going to add another length. This is going to be our height dimension. So that's going to be 5 millimeters. Perfect. Okay, so we have that. And then we are going to go into concept and make a surface from the sketch. So we're going to do this. And then for our base objects, select that. There we go. So now we have our surface. All right. Now we're going to go into mesh. Now workbench. Now I'm going to open this. Wait for that to open. Alright, so that loaded. We are going to bring all of our sections. So what we're going to do is go to edge, and then we're going to right click and then click create a section. This is our up wall. This is our lower wall. Okay. This is our inlet. That's strange. There we go. We're in the order. So now we have our stuff named. We're going to go into insert sizing. So insert sizing. Change that to intelligence. Radians is going to be 2500. And then I'm going to change the capture curve to no, so that we can change our behavior to support. Okay. Perfect. I'm going to do the same thing for our two side walls. So I'm going to go mesh, insert, sizing. I'm going to click these two. Those two edges. Type is number of divisions. Number of divisions is going to be 50. Good. And then capture curvature. No. And then behavior hard. Okay, great. So we have that, and then we're going to click face mesh. And once we click face mesh, we're going to select this geometry, and then we're going to apply it. Now we apply. We're going to go and update this mesh by right clicking on that, clicking update. Okay, cool. And then you can check your mesh if it got applied by clicking on mesh, and then it will show you that you have this mesh. So you're going to go back to mesh, and then you're going to click to update that. Then once it's updated, you're going to go into setup. So we're going to click edit setup so that we can change solver to double precision, and then we're going to click start. Okay, it all loaded. We are going to change a couple things. So we're going to go and change our model viscous from viscous to laminar. Okay. And then we are also going to change residuals. So here, these residuals, we're going to change this to 1e to the negative 6 for all of them. Okay, cool. Thanks. Okay. After that, we're going to go into our fluid. So until that, materials, fluid, we're going to go into air. We're going to change some things in there. So the density is going to be 1, and then viscosity is going to be 0.401. Okay, click change create. Okay, and then you can close it. Now you're going to change our reference values. Reference values. We're going to compute from our inlet. Great. Make sure those look good. Reference zone is going to be surface body. And now we're going to change our boundary conditions. So if we click here in our inlet, let's take a look at this. So we're going to change our velocity to 0.8, apply, and then you can close. And then you're also going to go to our outlets. There. And then all of these are going to be kept the same, but we're going to prevent reverse flow. Apply and then close. After that, we're going to make sure that our plates are all good. So our lower wall should be stationary. Perfect. There's no slip condition. Apply, close. Upper wall is the one that's going to be moving. So click moving, and then the speed is going to be 0.4. Yeah. Bringing no slip condition. Apply, close. After that, we are going to go to initialize. Click initialize. So it just initialized. Now we're going to run our calc. Click here, and then for our number of iterations, we're going to do 150. After that, keep everything else the same, and then you're going to calculate. Okay, great. Our calculation is complete. So now we're going to go into our results from our workbench. Actually, we're going to update that. Okay. Open up results. Okay, so now that that's loaded, we are going to add in our midline, our endline, and our developing flow region line. So to add in our line, click location, click line. Let's start with the midline. Okay, so the point is going to be at 0.125. Oops. Okay, and then also going to be at 0.005. And then sample is going to be at 100. Great, apply. See the midline? And we're going to add our endline next. And line. Okay. Coordinates for this are going to be at 0.24999. Okay. A 100 samples as well. That does not look right. Oh, this is so annoying. Alright, now we're going to add an endline. These are the coordinates for that. Apply. Beautiful. One more line is going to be the developing flow region. Flow region. Okay. Nice. Alright, so now that we have all our lines, we're going to make a chart. So click for chart. And then the title can be velocity profile for combined flow. Okay. And then we're going to include all the lines that we had. So for our series, we're going to include our midline. Okay. Endline. And then developing for the region. Okay. Great. And then we are going to make sure our axes are right. So in our x-axis, this is going to be velocity in the u direction. And then in our y-axis, this is going to be just y. Okay. And now we're going to click apply. Cool. So now we have this chart. Okay, so to this, we're going to add vectors and contours. We're going to do vectors, new, and then I'm going to do interior surface body, vectors of velocity, color by velocity, magnitude. We're going to click Save Display. Great. And then we're going to also add contours. So contours, new, contours of velocity, And then we're going to click the interior surface bodies above, click Save Display. If you can't get them to both show up on the same one, you're going to make a scene. So you're going to go to Scene, New, and then we're going to click both of these on, and we're going to click Save. And now we have our vector lines, and we have our vectors and contour lines. So we have that. We also have that graph, and from this graph we can find the maximum velocity, which I have included here. Maximum velocity turned out to be 1.08 meters per second at a height of 0.003 meters. We used all of our input data to plug into the Reynolds number equation, and that came out to 40. So thank you guys so much for watching, and have a great rest of your day. Bye!